Hello, we are on page 255. This is Module 2, Topic 2, Lesson 3. After this lesson, we'll be halfway through this topic, so we'll be taking a mid-topic quiz. Anyways, I think we're pretty familiar with, I think, the math behind the topic for today's lesson. The only thing is we're kind of interpreting word problems, so that takes some a little bit of analysis. But here at activity 1, it says choosing independent and dependent quantities. I do want to remind us though that I'm going to write this off to the side, that the rate of change or the slope is always the dependent variable over the independent variable, or y over x, change of y over change in x, or rise over run. So we're going to have to identify in these different situations which one is dependent, which one is independent. Anyways, so from there, we'll need a couple of points. Let's look at the context here on page 255. It says, Josh took a road trip with his family to visit Yosemite National Park in California. The table shows some information about their trip. They drove a total of 2,600 miles. Total cost for gas is $200, and they used up 80 gallons of gasoline. So think of those milk gallons, 80 of those, so quite a bit of gasoline. This context is going to be used for this page and also the next page, and we're going to interpret it in kind of two different ways. So the first one, number one, after they arrived, Josh was curious about how many miles per gallon. Let's highlight that. So miles per gallon their car got on the trip. So miles per gallon. I'm going to write that off to the side over here. I'll put MI over GAL. So that already there kind of tells us, right, which one is dependent over which one is independent. So it says, given this question, what are the independent and dependent variables? So we're saying that the numerator here is dependent. The numerator here is miles. So let's go ahead and put that, let's put that right here. So dependent is miles, and independent, right, just like I'll highlight this in a different color, I'll put this in red, right, independent is gallons. Okay, and for number 1B, we're going to write two ordered pairs given the information that we have, and then we'll also talk about the meaning of those ordered pairs. So when we write an ordered pair, we're always going to start at, typically we'll start at 0. So in this case, I'd like for you to put the coordinate 0, 0. So how do we interpret this? Right, this is, we'll put 0 gallons for 0 miles. Right, this is just us just barely starting our trip. The other thing that we have here is, we'll say, since the independent variable is x and the dependent variable is y, and an order pair is always x comma y. The other thing we have, right, x gallons, well, what do we have here that represents gallons? We have 80. And here, what represents miles? That is 2,600. Okay, so what does that ordered pair mean? This means, right, 80 gallons, and I should abbreviate it, to travel 2,600 miles. Oops. Okay, and then just want to be clear here, let's actually write out x and y. So x is gallons and y is miles. Okay, this is just us setting it up before we figure out any rate of change. Okay, and that's where we're going to get to the next part, C. So it says determine the rate. When we say rate, you could literally just translate this to be slope, right? Slope means how much we move, how much we increase, decrease. A rate is exactly the same, except we use slope when we have a graph. We don't have a graph here, so that's why we're saying rate. So what I like to do here is I like to line up the ordered pairs vertically. When you set up your slope formula, that is, I'm only going to write this once, right? y1 minus y2. The y's we subtract on top, and then the x's we subtract on the bottom. So what you can do here, right, you can just subtract the y's, that's these two values. And then divide that by subtracting the x's, that's these two values. I'll go from bottom to top because I think it's easier to do 2600 minus 0. So the rate is 2600 minus 0 over 80 minus 0. And this calculation right, not too bad. We'll get 2600 over 80. And then, so actually let's just write that. So what does this represent? This represents exactly what we use. 2600 miles for every 80 gallons used. Right, and that's considering that we're going at a constant rate. So we'll make that assumption here. So D, how many miles per gallon did their car get on the road trip? So miles per gallon. So instead of miles per hour, right, that's looking at speed, we're looking at how much we're using per gallon. So that is a rate. So what we do here is that's you just simplifying our rate. Now you can try to simplify this, or we have numbers that end in 0. So instead of doing 2600 divided by 80, you could do 260 divided by 8, right? And you can set up long division there. For the purposes of being efficient, though, I'm going to put this into our calculator. You're welcome to do this as well. 2600 divided by 8, or sorry, 260 divided by 8. All right, and that is 32.5. Okay, so that represents that this is, right, 32.5 miles per gallon. To put that in like perspective, like a marathon is 26 miles, so it's a little bit over a marathon. And I'm pretty sure 32.5 miles you can pretty much get anywhere in Las Vegas. Las Vegas isn't that big, but anyways, to give you an idea of like how big that represents. Okay, let's go and flip this over to page 256. So still continuing in that same context, but we're asking the question in a slightly different way. Okay, so we're gonna have to highlight something. The family wants to know about how many gallons of gas on average they use for each mile. So that is represented as gallons of gas every mile. So what we had in the previous side was how many miles per gallon. We have it switched now. It's gallon per mile. So let's write that off to the side so we don't forget that. Gallon per mile. Okay, so in this case, right, we talked about how it's dependent over, dependent over independent. So that's going to help us with number 2A. Given this question, what are the independent and dependent variables? We'll just draw an arrow and just write it underneath. Dependent is gallons, and independent is miles. So it's saying every 1 mile, well, how many gallons do we use? How many gallons of gasoline do we use? If you know that, let's say your car can travel, 400 miles, well, right, how many gallons will be used in that 400 miles? So let's write an ordered pair for this. It's exactly the same, well, actually not exactly the same ordered pair because now we have the X and Y switched, right? Independent, in this case, miles is X. Instead, last one it was miles was Y. Now gallons is Y. Right, so an ordered pair X comma Y. We're still gonna have 0, 0 because if I switch that does not change. Right, 0 miles, 0 gallons. But the second one, it does, and that is 2600 comma 80. Right, 2600 miles comma 80 gallons. So what we have here is just switched. So I'm gonna go back real quick. Right, that was here. Notice how we have 80 in front of the 2600. Okay. Anyway, so I like writing it vertically there because that's going to help us compute the slope formula. But let's go ahead and finish this off because for this one, you know what? Let's write out the variables. So X is represented by miles traveled, and Y, that is gallons used. Okay. Determine the rate. So again, I'm not going to write the formula out, but we know if we have to subtract the y's over subtract the x's. So this is going to be 80 minus 0. and then 200 or 2,600 minus 0. So this is a similar fraction to the last one, but notice how our numerator and denominator are switched. It does say here, explain the, in terms of the problem, so explain the meaning. This is, right, 80, the numerator is represented by gallons, 80 gallons of gas for every 2,600 miles drove. We'll put in past tense. Okay, and then here we for D, what was the family's average gallons per mile for the trip? And then round to the nearest hundredths place. So we are going to have to divide this out. And again, if you want to use some number sense to try to divide this, instead of 80 divided by 2,600, we could do 8 divided by 260. So let's go back to our calculator and want to round to the nearest hundredths place. So 8 divided by 260. Okay, we get this long decimal. 0.0, this 3 is in the hundredths place. So we always look at the thousandths place, so that's the 0 right next to it. It's less than 5, so it just stays like that. So this is 0.03. Okay, but let's also write it in terms of our problem. This is, we're going to write the unit underneath, or the 2 units, not underneath, sorry, side by side, gallons per mile. Okay, so it's saying every single mile we use this very, very small amount of fuel. Right, this is, if you want to think about it, how small this is in terms of money, in terms of dollars, that's 3 cents, right? So 3 cents compared to a dollar is not that much. But we're not representing dollars here, right? This is just 3/100ths of a gallon. Okay, or 3% of that milk gallon, if you want to think about it in those terms. Anyways, we're going to skip number 3. This is not a you-do. You will have you-dos later, but we're going to skip this problem. I think we get the idea from that first 2 contexts. Okay, so let's go to, we're done with activity 1. There's only 2 activities, so we're on 2 of 2, but this we'll be skipping quite a bit. There's quite a bit of stuff that we have to do here. In activity 2, it says determining slope and the y-intercept. And again, I want you to think of the y-intercept as where we begin, the slope as how much we're moving, meaning how much we're increasing and decreasing. So a couple of things that it's asking us. For each context, complete each task. We're going to identify the independent and dependent variables. We're going to write the ordered pairs of 2 points, so ordered pairs, and explain what each of the ordered pair means, so the meaning. So we're going to write a sentence there, and then we're going to determine the rate. So just like what we did for the last one, but we are going to go through a couple of these. We're going to go through 1 and 3. We'll skip 2. All right, but let's keep our calculator saying. So the hardest part here, I think, is writing the ordered pairs. But let's try to interpret it from this context. So what's independent, what's dependent, first of all. So it says Bella's Pizza Shop charges $9 for a large pizza, and any toppings ordered cost extra. Bruce ordered a large pizza with 3 toppings. That costs a total of $12.60. What is the cost per number of toppings for a large pizza? So let's highlight a couple things that are important here. Where we know that these numbers are important. So a pizza just costs $9 just to start. So that's where we begin. And then we also have that we have 3 toppings, and that those 3 toppings raise the price, right? It's now $12.60 versus 9 cents, or sorry, dollars versus $9. And we want to figure out what is I'll put this in a different color, cost per number of topping, should just say cost per topping. Okay. Now, what we're going to have to do here is we have to look at the increase. So what you can do, you don't have to set this up using the formula, but if we go from $9 to $12.60, what is that difference? And whatever that difference is, we're dividing by 3 since there are 3 topics. That's how you could find that out. But we'll go through this more logical, I guess, way of going about it. So in this case, independent and dependent. Okay. So it says cost per topping. That actually gives you the fraction. Since we know it's always dependent over independent, cost per topping. Okay, so we're gonna, so dependent, that's the numerator. That means it's the cost, so I'll put cost right here. And the independent, that's the denominator. That tells us its number of toppings. Okay, great. Now that also gives me an ordered pair too, because the ordered pair is always x comma y. So let's think about. We're always gonna, like I said, we're always gonna start at 0. So let's think about 0. You can't have 0 pizzas, but we can have 0 toppings here. So a pizza with 0 toppings, how much does that cost for y? That is $9. So that gives us a little bit of something to interpret there. Actually, let's write that in while we're at it. We'll say a pizza with 0 toppings, I'm going to abbreviate, costs $9. And then the other thing here, so instead of 0 toppings, there was some information with 3 toppings. 3 toppings, and that cost us $12.60. I'll put 12.6. It means the same thing. This is a pizza with 3 toppings. Costs, $12.60. All right, now comes the part where we are figuring out the rate. We're going to have to squeeze this in here because we're running a little bit out of room. Okay, so the slope or the rate, change of y over change in x. So let's subtract the y values. Now it actually doesn't matter. You could do 9 minus 12.6. As long as for the other one, you put 0 minus 3. Right, you start with the same point. Or I could do 12.6 minus 9 as long as I do 3 minus 0. And you know what? I'll do it that way. 12.6 minus 9 divided by 3 minus 0. Or I'm just going bottom up, bottom up. We got to start at the same place. We talked about this in a previous lesson. Anyways, what's 12.6 minus 9? Well, what's 12 minus 9? 12 minus 9 is 3. I got that 60 cents on top of it. So it's 3.6. And then 3 minus 0 is 3. Now this, we can do some mental math here. We're not going to use a calculator. How many times can 3 go into 3? It's 1. And then how many times can 3 go into 6? That's 2. So it's 1.2. This, answering our question, what is the cost per topping? It is $1, and we'll put a 0 here. 2/10 is the same thing as 20 hundredths. $2.20 per topping. Or sorry, $1.20 per topping. All right, good there. No, not too bad, right? We had to identify what is independent, dependent, and that came from the question. That helped us quite a bit. We wrote down these ordered pairs, right? So that is maybe right, kind of, there's a level of complexity to it. So we have to be careful with how we set that up. We know how to subtract, set up as a fraction, simplify that fraction, and we answered the question. Good. Let's go to number 3. We'll skip number 2. Okay. This is talking about Melanie. So Melanie, is she a baker? Yes. So bakes 15 dozen. So dozen is 12. So 15 dozen, you have to multiply, 15 times 12. 15 dozen breakfast rolls in 3 hours. Right. So that's a key piece of information there. After 8 hours, she has baked 40 breakfast rolls. At what rate does Melanie bake breakfast rolls per or each hour? Okay, let's write that out. So again, it's dependent over independent. And this is rolls per hour. Okay, now the first thing we have to do, right, we have to identify the independent dependent variable. We kind of already did that here, but let's write it out explicitly. Right, what is independent? Independent is hours, so time in hours. And dependent is number of rolls baked in terms of dozen. We'll just say number of rolls. And I'll put a dozen in parentheses, just so we know what does it represent. Okay, now comes the time where we're writing ordered pairs. We typically start at 0, 0 or 0 for the independent variable, but we're given quite a bit of information. So let's write that out, or let's highlight this. 12 dozen in 3 hours. That looks like it's an ordered pair. And then separately, 8 hours, she's baked 40 dozen. Okay. Now, if you're not sure how to write this, whether it's the first one's going to be 15 and using N3, is it 15.3 or 315? All right, well, let's use some clues here. It's always x comma y. We know that the independent variable is x and the dependent variable is y, just because it's always y over x. So we're going to have time be the x variable. So time in that case is 3 hours. And then 15 dozen, we'll just put 15. Right, for the y variable. So this is represented as 15 dozen, or sorry, 3 hours. And I'll just put comma. 15 dozen rolls baked. I could have wrote that a lot better, but we'll just keep it like that. And then the second thing here we're gonna put is what I have in orange in terms of time: 8 hours, 40 rolls baked. Or sorry, 40 dozen rolls baked. Okay, now comes the time that we're going to set this up. Let's subtract our y. So we're going to put, I'll do 15 minus 40. I'll start at the top one this time. That means that for the x, I got to start on the top one. So this is 3 minus 8. Okay, let's simplify. 15 minus 40. All right, different signs, so you have to subtract them. 15 minus 40 is a negative 25. And then 3 minus 8, same thing, different sign, subtract, keep the sign of the bigger number, it's a negative 5. We can simplify that, we don't need a calculator. This is negative divided by negative is a positive, and 25 divided by 5 is 5. So our final answer here is 5 dozen rolls per hour. Or, right, what's 5 dozen, right? A dozen is 12, 5 times 12. We could also put that this is 60 rolls per hour. Okay. All right, good there. Right, so 60 rolls per hour, right? That's quite a bit for every hour. That's if you were to put that in terms of minutes, that's 1 roll per every minute. So that seems like a pretty efficient thing that they got going on in this bakery. Okay, let's go to page 258. We're skipping number 4, but we are working on 5 and 6. Or I might leave one of these as a you-do, and then we'll get to one more on the back. Okay. Actually, let's just do one more. You know what? I'm going to say let's leave number 6 as a you-do. We'll do number 5 and then go to the backside. Okay, we're going to go a little bit faster though. So number 5, it says Eddie rented a moving van to travel across the country. The odometer registered this many miles after he drove 4 hours. So let's highlight that for now. Okay. And then after 7 hours, but it's in a different color, we now drove this many miles. How fast was Eddie driving? His rate in terms of miles per hour. Okay, miles per hour. Right, so that's more kind of common here. All right, miles per hour, we know that it's going to be, for the first one, miles per hour, we know that miles is going to be y, hours is going to be x. Always x comma y, so we're going to put hours before miles, and at least as an ordered pair. So the first one is 4 miles. All right, 34,567. And the next one in purple, 7 hours, 34,741. So those numbers are, I know those numbers are big, but they're actually not too far from each other if we set it up. So now let's divide this. Actually, I should have put this vertically. Let's do this. Just so it kind of helps when you set up the subtraction algorithm. All right, let's subtract those two values. I'm gonna go from bottom up here. So let's do 34,741 minus 34,567. And we're going to do 7 over 4. That's a little bit easier than the first one. You can plug this into your calculator, but I'll go and give this to you. This is 174 miles for every 3 hours. So that's good to know, but we want to know how much it is per 1 mile. So not 3 miles, or sorry, 3 hours, 1 hour. So let's divide that. 174 divided by 3. Oops. Okay. 174 divided by 3. That's 58. All right, so this is 50 miles per hour. So that's pretty fast. That's like going on a freeway. Well, a freeway is 65, so that at least gives you something comparable to it. Like driving down Washington, I'm pretty sure that's 35. So 58, if you want to like kind of gauge how fast it is between those two speeds. All right, great. Anyways, I'd like for you to try to figure out number 6. Number 6 does have some decimals, but you do have a calculator of 42, so use that calculator and identify those important pieces of information. Let me know if you'd like for me to check to see if your answer is correct. All right, let's go to the next page. We'll do one more example. I'm going to do number 7, leaving 8 as a you-do. Okay, so here we're putting something additional, and that is identifying the y-intercept. We did do a problem like this in the previous lesson, the previous video. So it says, determine the y-intercept using the slope formula. Write the y-intercept in coordinate form and explain what it represents in the situation. Okay, so let's read the context first. Kim spent $18 to purchase a ride all day pass for an amusement park and to play 8 games. Okay. After playing a total of 20 games, she realized she spent $24. Okay, so some things here, we can represent some ordered pairs. Let's think about independent and dependent. The first ordered pair is going to be 8, 18, using this and this. So we have this in terms of games and dollars. Okay, games is X, dollars is Y. For this, let's go and identify the other piece of information that probably has to deal with this 20 and this 24. I'll write this vertically. That will be 20. So we're talking about $20 and 20 games and $24. So games and dollars again. All right. Now, before we start with this, we do have to figure out the slope. So let's figure out, it is 24 minus 18. And, oops. Let's fix that. 24 minus 18. Divided by 20 minus 8. Okay, numerator is going to be 6, denominator is going to be 12. Now for this, okay, yeah, we get a proper fraction, but we can simplify that. That is 1/2. All right, so 1/2, or half of a game every dollar. Okay, so half of a game every dollar. Or 1 game for every $2. Okay. Now let's identify the slope intercept, or sorry, the y-intercept here. So how we figured this out, we have to use this piece of information, and for this we can actually use just one of the points here, because we want to find what is the y-intercept, which is the y variable. I'm going to use this first point. So if we rewrite this, we talked about how I'm going to put y minus y1 over x minus x1. I'm not putting the 2 here just because we don't have a second point. We're just using 1 point. We're using this as x1, y1. I'll plug in our slope, though, which we just found was 1/2. Okay. Now, when you find the y-intercept, this is always where the x value is 0. So we're saying for this, it's 0 games. Okay. So for this first part, it's going to be y minus y1 is 18. And we're saying 0 games, so 0 is going in for x. So how many dollars is it for 0 games? So what are we starting at? And then minus 8 for x1. Now here, right, we can simplify this. 0 minus 8 is just -8. So I'm actually just going to get rid of that 0. So this becomes a 2-step equation. I'm going to multiply both sides by negative 8 because we're undoing dividing by 8. Negative 8, sorry. Okay, we'll rewrite this. Negative 8 times 1/2. Well, what's a half of 8? It's 4, so this is a negative 4. Okay, and then this is a one-step equation. Now we're going to get rid of subtracting 18 by adding 18 to both sides. And then to simplify this, this is 14 equal to y. So y represents dollars. So this is saying that when you begin, you have to spend $14 to enter this, this amusement park. So it's going to put that here. So this is going to be as a coordinate though, right? It's always x comma y. We said that x is 0 and y we just found is 14. So that's how you write this. But we don't want to put the meaning of this, so let's write it explicitly. So the cost to purchase the pass, right, to enter the amusement park, and play games is $14. Okay. You're going to do something similar to this for 8. Again, this is a you-do, so check if you're finished, but we'll call it there. Oh, sorry, the assignment. The assignment, we're going to skip talk to talk. If you go to page 261, we're doing numbers 1, 2, 3, and 4 on the front side, and then on the back side, 5, A, and B. Okay.